This is some continuation of lesson 2.2, and here we're going to look at Theorem 2.7, limit of inequality. Suppose the limit of a function f of x as x approaches a is L, and the limit of g of x as x approaches a equals to n. And also, if f of x is less than or equal to g of x for all x in some interval about a, just saying a here, then the limit, since f of x is less than g of x, then the limit of f of x, L, is going to be less than the limit of g of x, which is m. And so we want to reach a contradiction. Reach a contradiction. Okay, so the way we're going to do that is we assume that L is not less than or equal to m. We assume that L is greater than m. Okay, and so we know that's not true because the theorem states L is less than m. So, but we want to achieve a contradiction. So we're assuming L is greater than m, and also we're going to assume that epsilon is L equal to L minus m over 2. Okay, so the first thing we're going to do is we're going to work with this epsilon equation. So here we're going to rewrite it here, epsilon equals to L minus m over 2. And so basically we're going to divide out this denominator. So we're going to multiply 2 to both sides. And so we get 2 epsilon equals to L minus m. And then we're going to say, all right, 2 epsilon is the same as epsilon plus epsilon equals to L minus m. So now if we apply plus m to both sides, plus m plus m plus m, we've got epsilon plus m equals to L, and then we're going to subtract one of the epsilons. Minus epsilon, and so we've got epsilon plus m equals to L minus epsilon. All right, well, why do we want to do that? Well, because when we look at f of x, for example, now let's set this aside for a moment, and let's look at, now we know that the limit for f of x minus L, or the limit of f of x as x approaches a equals to L. And let me rewrite that. Limit x approaches a for f of x equals L. All right. So we also know that the absolute value of f of x minus L is less than epsilon. So if we were to solve for f of x, we would do away with the absolute values. Minus L is less than epsilon, but it's greater than a negative epsilon. So we do this when we're solving for an absolute value problem. Okay, so now we can apply plus L plus L plus L. And so we get here L minus epsilon is less than f of x, and that's less than epsilon plus L. Okay, so now with that, now we're going to look at g of x. And so we're looking at the limit as x approaches a for g of x equals to limit m. So we can say here that g of x minus m is less than epsilon. Okay, so we're gonna, and that's of course for x minus a is less than delta. All right, so from here, so this would be 4x minus a less than delta, and this would be same thing here, 4x minus a less than delta. Okay, so now we're going to do away with the absolute value. G of x minus m is less than epsilon, but is greater than negative epsilon. So from here, we're going to apply plus m plus m plus m. So that's going to give us m minus epsilon is less than g of x less than epsilon plus m. Okay, so from here, now this is where this comes in. Here we said that epsilon plus m, excuse me, epsilon plus m equals to L minus epsilon. Okay, so f of x is greater than L minus epsilon. So we can say that L minus epsilon is less than f of x. And we can say that g of x is less than epsilon plus m. So epsilon plus m is greater than g of x. So since epsilon plus m is equal to L minus epsilon, then that means that g of x must be less than f of x. Since g of x is less than epsilon plus m, and that's equal to L minus epsilon, and f of x, and that's less than f of x, so g of x must be less than f of x. But that's a contradiction to what we said here. We said f of x was less than or equal to g of x. But f of x is less than or equal to g of x. So that's a direct contradiction. This is a contradiction. This is a contradiction. Therefore, f of x is less than or equal to g of x, where L is less than or equal to m. So since g of x is less than e plus m, and then e plus m is equal to L minus e, and L minus e is less than f of x, then g of x must be less than f of x, but that's a direct contradiction to what our original statement was, which was f of x is less than g of x. So that means, so g of x can't be less than f of x because f of x is less than or equal to g of x. So this is a direct contradiction. Therefore, f of x is less than g of x, where L is less than m. And that holds. And that is our end of our video.